Welcome everybody to Integrated Math 3. In today's episode, we will be continuing our Chapter 11 journey with Chapter 11.1.3, which is adding and subtracting rationals. Basically, adding and subtracting fractions. We've talked about it 2 episodes ago. We talked about it in the last episode. A rational expression is simply a fraction. There's nothing more to it. So, the reason why this shows up after the multiplication and the division bit is because when we add and subtract rationals, when we add and subtract fractions, we need to get something in particular that can be a bit tedious at times. Let's go ahead and review what that is. If I was to add 1/4 plus 1/3, right now I would not be able to do that. And that is because the denominator is not the same. In order for me to add these fractions appropriately, I need a common denominator. Now, by now, you will probably be able to identify that denominator was definitely 12. The question is how did we get that? It's because if I was to take this 4 and I wanted to turn him into this 12, I'd have to multiply him by 3 on bottom. But I can't just multiply the 3 on the bottom. I have to multiply a 3 on the top as well. Same thing happens here with this 3. I can multiply the bottom by 4 to make the denominator 12, but then I got to multiply the top by 4 as well. I'm going to multiply those dudes in to get 3 over 12 and 4 over 12. Effectively, what I'm doing when I get a common denominator is I'm unreducing my fraction. Now, because they have the same denominator, of course it's going to be 7 over 12, we know that. But I'll go and just do this move here because I'm going to do this a lot in the integrated 3 version. I'm going to put them over the same denominator, 3 plus 4 over 12 collectively, which then becomes 7 over 12. Again, in the scope of pre-integrated 1, not a totally necessary move for this guy to happen, but you'll see me do this a lot in the integrated 3 version of this because it does in fact help, especially when it comes to the whole subtraction bit. So that is the basic premise of today's lesson, and that is how do we obtain a common denominator when we have something a little bit more complicated happening. So let's take a look at something like this. Let's take a look at another simple example actually before we move on to this. If I did, say, 1/3 plus 1/6, what would be the common denominator? Well, the common denominator could be 18, and there's nothing wrong with that. If you did exactly what we did in the last example, you'd do 3 times 6 to get you 18, and there'd be nothing wrong with that. But if you look really closely between the 3 and the 6, the common denominator could actually be 6, and that's if I was looking at the LCD, which is what we call the least common denominator, right? And so in order to get the 3 to become a 6, I had to multiply the top and bottom by 2 over 2. Now the right side didn't need anything, so I was multiplying by 1 over 1. So what I get is I get 2 6 plus 1 6, and I end up getting 3 6, which is 1/2. Hopefully that makes sense because that's going to be applicable to the first example that we do. In the integrated 3 version of this, what I have is I have this example, I'll call them example number 3 here. It's going to be x over 3x plus 1 plus 2x squared minus 2 over x minus 5 times 3x plus 1. So we have to add these two fractions together. We have to get a common denominator. The common denominator that exists between this guy and this whole shebang, you really don't want to think too hard. The common denominator is going to be this whole shebang right here. So how do I make this fraction on the left equivalent to this fraction on the right? What does he need in order to become that fraction? Well, remember in the past, what we did is we multiplied each piece by what they were missing to become that common denominator. So if we can identify that common denominator, and actually I can go ahead and pause if you want to and identify it by yourself. That common denominator is x minus 5 times 3x plus 1. So what did the left piece need in order to get itself to be that value? Well, he needed an x minus 5. And I can't just multiply the x minus 5 on bottom. I got to do it on the top as well. So what I'm going to do is I'm going to go ahead and distribute him in, and I got x squared minus 5x, and then I've got plus 2x squared minus 2. Again, here's that move, right? The one where I put the two added pieces over the same denominator. I just did it right here. And now I'm going to go ahead and combine my like terms. I get 3x squared. The negative 5x cannot combine with anything, so he comes along for the ride. Minus 2 over, looks like 3x plus 1 times x minus 5. Okay. I feel like that might be as far as we can go. We will have to put some excluded values in here. The excluded values really just come from the denominator only. There's nothing more complex because I'm not dividing anything. It'll be x cannot equal negative 1/3 or 5. So that's really it. It's just that whole notion of getting a common denominator. Let's go ahead and try another one real quick. I'll be right back with the example. Okay, here comes example 4. We've got 5 over x plus 3 minus 2 over x minus 2. We actually could start off with just the excluded values here and just say x cannot equal negative 3 or 2 in this case. So let's talk about common denominator. Well, this one is most reminiscent of the first example that we gave, where if I had 4 and 3 as my denominators, the common denominator was 12, and that's just gotten by multiplying the pieces together. So I'm just going to take these pieces and multiply them together. So I've got x plus 3 times x minus 2. So let's take a look at what we're missing on each piece. What was the right piece missing? What was the left piece missing? And to determine that, just look at the denominator. What does he need to have next to him? This guy needed an x minus 2, which also must go up top. This guy needs an x plus 3, which also must go up top. So now I'm going to go ahead and distribute that 5 in. I get 5x minus 10. Now, when I distribute this 2, and here's where you want to be careful, I am not distributing a 2. I am distributing, watch this, I am distributing a negative 2 in. So please be careful about that because people make that mistake often. So what I've got is I've got negative 2x and then negative 6. Again, it's because I'm distributing a negative 2 in, not just a 2. And that happens every time you subtract. So please be careful on that subtraction. 5 minus 2 is 3x. The 10 and the negative 10 and the negative 6 become negative 16, and you're left with x plus 3 times x minus 2. Do not worry about remultiplying the bottom. It really does nothing for you. So you have your answer. I believe the excluded values were up there at some point early on, right here. And there you go. That's how you add and subtract rational expressions. So again, that whole bit is finding that common denominator. That's what this lesson is all about. So hopefully that all made sense. Please leave questions or comments in the comments area. I will see you all in the next episode.